Okay, sir, can you see my screen? Continue, can you see my screen? Hello? Hello? Mr. Sue, are you with me? I can't hear you. I can't hear you. I just sent a message in the chat section whether you can hear me.
Hello, I can hear you.
All right, I can hear you now. So, can you see my screen?
Yes, I can see your screen.
All right. So,
I bought one book on how programming.
okay, what's the name of the book, sir?
R programming fundamentals.
How
R programming.
Okay, how
R
programming
programming.
fundamentals.
Mm.
Okay. You hard copy or soft copy?
No, it's a soft copy.
Okay. I think that will also help. That will also really go down with.
From your experience, is the exam, what percentage of question comes from R knowledge of R and
A lot
a lot?
of questions come from that. Like over 30%.
Okay. You know, most exams that I have done, let's take project management for example. They will tell you the percentage from various areas, the percentage of questions you should expect from various areas.
Okay.
But this DASCA exam is a little bit, it's like there isn't much information around.
So it's if you go to DASCA website, you see the breakdown. Or let me say that
How
I
do you
have,
break it down, Abi? Okay, I think I've seen it before. That's
yeah.
true. I'll go back there.
But then those breakdown might not really I don't know.
They don't follow it strictly.
Maybe it does not really go per se like that, but then they are going to touch like almost everything, but how is going to be plenty, like really plenty of questions. How should
Yeah, because I'm saying that since we enter hard for a long time, we are still on it. Maybe because it's also a programming, there's a programming something behind it.
yeah.
That's what I mean.
So we are going to continue the lab. The lab for module 3, that's what we'll be doing today. I hope we can finish it. I just hope we can finish it. So on that downloads, so the first lab there, that would be okay. Okay. Working with functions. Is talking about data analysis in R. Yeah, this where is it? Yeah, this lab, working with functions. So that's the first lab we're going to do. It shouldn't take us much time, so I'll just copy this. Copy. I'll go over it. All right, so let me start from very first 794. So, uh, okay, I started from here. So here, are we starting from here? Working. Okay, yes. So here they created a variable called person names. They created a vector for person names, which includes names of people. Then they created a vector called spending, This contains probably the amount they spend. I don't know, maybe monthly or weekly. These are the amount they spend. So each of them correspond to the name. So Andrew spent this, Chingu spent this, and in that order. So this is profit. Okay, this is their profit. Now we're now saying, okay, we're going to create a bonus, which is going to be profit minus spending. So after, so they made profit from probably they did the business, they made a profit of this amount, and out of the profits they spent this amount. Then what is left, like, are calling it bonus. Now, okay, so let me create this basic system. So I run this line of command now. I'll run this. Let me run this also. Let me run this also. So if I want, by the time I run this line, it means it's going to do this guy minus this guy to get my profit, to get my bonus rather. So the profit minus spend. So let me run this. So that will give me my bonus. So I want to now create a data frame called bonus details. And this bonus details is going to contain the person's names and the corresponding bonus. That is after removing the amount they spent from their profit. So you can see the name of that person and the bonus the person has. So if I should run this line now, okay, I should have the bonus details. You understand what we just did from here? You understand this line of command?
Yes.
Okay. So let's print. Let's see what is inside. Now we have this. So Andrew has this bonus left. Chingu has this bonus left. Okay. Uh, sorry. So here, you know what source the source function is used to do? It is used to source a script. So probably I've created a script now. I've written a line of code. I've saved it as a .r extension file. Say
Okay. I
so
thought is it used for to bring data set also?
no. This
That one
data,
is low.
is it this? Are you talking about this
This
guy?
source function. I'm
Uh,
saying that is to bring a script. And I said, is it used to load the data set also, or is it a different function?
no. So it's used to source a script. This data set is just the directory of where the file is. That's what this one means. Say this carbonus.r script is
I
inside
know.
this.
If I have downloaded the data from, let's say, IMF, can I use this source to bring it into this source function?
No.
Okay.
It's used to load your script, like to help you load and run your script in R. That's what it does.
Okay.
So let's say this line of command that I wrote here, from this place from this place down to this place, I've written it in a script called carbonus.r. I wrote it in a script and I saved it as carbonus.r. And let's say peradventure I want to now run what is inside that script. I'll just use the source function and put the script name. If the script is inside my working directory, I'll just specify only the script name. This one will not be there. But if it is not in my working directory, I have to specify the location of where the script is. Then using the source function, by the time I run it, it's going to run the codes inside that script line by line. So let's say, for example, is this line of code I want to run. It means it's going to run this, followed by this, followed by this, followed by this, and print this last statement. And you're going to see this guy on your screen. Immediately the source button and source and the program's ends, you're going to see this information because you said it should print it, so it's going to show it on in your console down here. All right. So now we want to create a function here. So let's see how we create a function. So this function is creating is called calculate bonus. So I call the function calculate bonus. And how do I create it? I'll use the function keyword. This keyword function. I will say is equals to function. Then I'll put a brace, this parenthesis. Now in this parenthesis, you can see there is nothing inside. Means it means that this function is not taking any argument. It's not taking any argument. Now, after the function, you now put this brace. So inside the brace is what you want the function to do. So inside this function, I'm assigning a parameter person's name. I'm assigning a variable person's name to this vector, which has this name, and I'm also including spending variable. I'm using a plus sign to say, okay, I'm also doing this. So it's not that it's adding it, it's not adding it. So I'm saying, okay, I'm including spending to be this, I'm including profit to be this, I'm including bonus to be this, which is profit minus spending. Then lastly, I'm not saying bonus details should be the data frame combining person's names and bonus. So plus, what do I want it to do? Return bonus details. That is, this is saying that print the bonus details after you have done this command, this line here. It's going to bring it line by line, like in that order. By the time it gets to this place, it's going to return bonus details. So what we just did here is that we just compiled what we did here as a function. Everything we did here, we just put it inside the function called calculate bonus. But this is more is a static function because I've defined what I want to use inside the function. If you want it to be dynamic, it means all these parameters here, it has to be an argument so that anybody that wants to use it can define their own person's name, their own profit and bonus and all of that. But here is static because this function is just going to use what is here. So it's just going to returning the same result because it's using what you have defined inside it to calculate your bonus. So if I should run this now, now it has created that function. Now, so if I want to call this function, this calculate bonus function, I'll just type the name of the function, then put the brace. Since there's no argument, this parameter parenthesis will be empty. So since there's no argument, so if I should run this, all you just need to do is go inside this thing and do whatever I said you should do inside this function here. So if I should run this now, you can see it printed what my bonus details, which is the person's names and the corresponding bonus. That's a static function because it does not take any argument. Okay. If I should just run this line, it just shows me the structure of my function because if I wanted to run it, I have to put parentheses, but without parentheses, it just shows me the structure. But so if I run this now, you can see this is structure. It tells me, okay, this is the function, and this is what the function is doing. Whatever. So it just shows me everything about the function here. Okay. Now here, I'm assigning what M bonus cap to what calculate bonus. It means this is the calculate bonus I created. This is the calculate bonus function I created. Now I'm not assigning it to another variable called M bonus cap. It means that by the time I do this M bonus cap function, this calculate bonus function will pass its attributes to this guy. So it means at this point, this guy can also do what this function I created earlier is doing. So that's what it means. So if I should run this place now, if I should run this guy, it means now this guy is capable of doing what this function that I created before is doing. So if I should run this M bonus cal and put a brace, it's going to return the same result. So you can see it returns the person's names and the bonus corresponding. Okay. Okay, this one is saying returning values by default. Now, this one is the essence of putting what's it called? What is it? Okay. Yeah, I'm creating the function, and inside the function, I'm still doing the same thing, but I didn't specify the return statement. So I don't think this one is going to print anything if I should call it. So let me run this. You know, instead of after I created this bonus details as a data frame, the next line I'm supposed to put something like maybe print it or return it, but I didn't put anything. So let me create this function. So let me highlight this and create the function. I've created the function again as calculate bonus. Now I don't want to run print calculate bonus. So let me just put calculate bonus and run it for you. Calculate bonus. Let me just run ordinary this. You can see that it didn't return anything after I ran it. The reason is that inside this function, I didn't say it should print something or return anything. But if I want to return something, probably I will just put the print inside the print function. I'll put the calculate bonus. I can put something like this. Let's see what it's going to return. You can see now, it just returned the what's it called? The calculate bonus. The bonus details variable for me. Do you understand? Hello, are we still together? Hello. Okay. Instead of using the print function, I said if I put the calculate bonus function inside the brace, or sorry, inside parentheses, it should still do the same thing as when I do the print function. So let's try this out. So you can see it still prints the same result. All right. Now, in this line, we want to create a function with that is going to have an argument. So here I'm saying total bonus. I'm creating a function called theta bonus using the function keyword, and it takes one parameter, say x. Now I'm not putting a brace, so I'm using a space. After a space, I can define what my function is going to do. But then it's not. I don't. It's not always proportional without with you not using a brace when creating a function. The brace will guide you in your function so that you not lose focus, or it will make your code more readable, and you won't get confused at the level. So the brace really helps you. So now after this I put a space, then what do I want it to do? I say sum inside the sum, and I have as dot numeric inside the as dot numeric, and I have as dot vector bonus details for the second column. So here, first of all, I'll start from inside outside. I'll start from inside out. So here I'm saying, okay, I have the bonus details. I have a variable called bonus details that I created that has the person's names and the corresponding bonus. Now I'm not saying it for the second column in the bonus details. Now the second column is the one that contains the bonus, the bonus values. So I'm not saying that second column, convert it as a vector, then convert it as a number, as numeric. It's actually a number. I don't know why they actually do this, but it's still, no offense, it's still going to do the same thing anyway. It doesn't affect your result. So I'm saying, okay, after converting to a vector, convert it to a number, then sum it. So it's going to sum this plus this up to the last number and give you the result. So that is what this function is going to do for you. But then, as you can even see here, is not. I'm not using the x inside this function I'm creating. Hello, Mr. Tony, are you here? Hello. There's something wrong. Okay, I'm not passing the x. I'm not using the x inside this function, but that's not a good way to write this function. But then, so let's run it. This function has been created. So this tab bonus, I'll pass my bonus details as an argument to it. So let me run it. So it gave me the total of those possible those bonus. Now I want to try something. So what I'm going to try now is I'll this function. I'll write this function again. I'll use another. I'll not use bonus details as an argument. So let me use a vector 1 to 5. Can you see? Give me the same result. Using mean that this argument itself is not used inside this function. That's why I say the way this function is being created does not really make any sense to me, because this function is built whereby any argument you pass in is not going to use it. It's just going to use it's just going to do what you want it to do inside this place. And what you want it to do is working on an available variable before. So it's not using this x at all. So anything you pass inside it is not going to work with the x. It's just going to work with what you have inside here, which is the bonus details. So it just needs you to pass something inside the function, because if you don't pass anything inside the function, it might not return anything. It's just going to tell you that. So let me run it without the parameter. So it ran. It ran. I don't know why it ran, but it ran because x here is not actually used here. So if I don't put anything, it doesn't have any issue. It still goes to run my function for me, because even the x here is not even used inside the function. So that's why I said this function does not really make sense within that way. I don't know the point of putting x if I'm not going to use the x. All right, moving forward. Here I'm creating a function called do sum. This function is going to take a parameter x, then it's going to sum my x. So x can be a vector, x can be a number, and I want, but if you don't want to sum it just a single number, it doesn't really make any sense. So I can run this now. I've created that function. So let's say I want to create a vector called some values, which has the set of number. Then I want to sum this number. I can just use the do sum function that I've created, which is going to give me the same result. This result, which is 6,834, which actually sum what is inside here. If I just use the inbuilt sum function, it's just going to give me the same result. Some values, the same result. So it just gives you the sum of what is inside this vector. Okay. Adding a default value to your function. Here I'm creating a function called multiply x. What does it contain? The function has two arguments or two parameters, x and y, but y has a default value of 10. Now remember, it's a default value, it's not a static value, it's not a constant value. So, and what does it do? It multiplies x with y. Now this default value is that, okay, but eventually I want to use this function. Let me create it. Okay, it has been created. But eventually I want to use this function, and I specify only one parameter. Now this first parameter is going to be considered as x, because x is the first in line here. Now, since I didn't specify a second parameter, it's going to use y to be 10. It's going to take y to be 10. So it's going to understand, okay, you didn't specify y, so I'll just use the 10, which is the default value I created. So it's going to do 3 times 10. And I'm going to have 30 as a result. So if I should run this now, you can see I have 30. Now, if I should run this is a vector. It's just one argument, so it corresponds to x only. Y2 is not specified, so it's going to multiply 10 to all the elements in this vector. So I will have 100, 200, and 300. Let me run this. You can see 100, 200, and 300. Now, here, I've specified my y. My x is this vector, while my y is this 5. It's not going to use this 10 because I specified y. So this code is just going to use this 5. So what it's going to do is multiply 5 by this vector, and I'm going to have 50, 100, and 150. So let me run this. As you can see, 50, 100, and 150. It's not something difficult. Hello, all together, man. Now here, talking about conjuring tricks with dots. These dots is not trick. So what this one is doing is say, okay, I'm creating a function called car%, and the function is going to take x as a parameter, as the first parameter. Let's take this as the second parameter, which has a default value of 100. Now, and I have another third parameter which is dot dot dot. This dot 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 means that I can still take optional parameters. Peradventure, if they are called in the body of the function.
May try.
Are we together? Hello? Hello? So here, what do I want the function to do? I want to multiply x by multi-factor and round it up to how many decimal place or row. So that's where this dot 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 is used to. So peradventure, I specify a third argument. This takes two arguments by default. Then you have optional parameters which is dot dot dot. Peradventure, I specify another argument, say 3. This 3 will be used in this place because the round function can take up to 2 arguments. So if I specify 3 as the third parameter when using the function, the 3 is going to round this operation to 3 decimal place. Then it's going to move to the next line and paste this is what I have here, percent, and append it towards the percentage sign without a space. You can do the separator is just a quote without space. So just join them, append them together, and print it on the screen. So let me create this function. Okay, so let's create a vector called values. Then I want to use the function on this value. Then I want to specify another parameter called digit equals to. Now, digit is equal to that I specify here is not the second parameter. It's part of this dot dot parameter. And why am I writing digit is equal to 2 when digit was not mentioned? Because actually the second parameter inside the round function is called digit. So it's going to be used here. So that's why I can say digit is equal to 2 because it is going to be used in this place, and digit is a second parameter in a round function. So since I didn't specify the multi-factor parameter, it's going to use 100 as the value. It's going to multiply these values by 100 and round it up to 2 digits. To like 2 decimal place. Then paste the result in this with the percentage sign. So let me run it. You can see 45 times 100 is 45, and 4 times 100 24, and the like. Then round it up to 2 decimal place. This does not have a decimal place, so you just leave it like that. And pasted the percentage sign together with the number and see the result on the screen. So that is that. And here I'm creating a function per percent having three parameters and optional parameters, which is this dot dot dot. Now this third parameter is taking a function. Now there's a function called signif. I can see signif is a function in R. So it's taking a function as a parameter called signif. So this signif, I think what it does is just round a number of a certain significant figure. So let's say I want to say signif say 2465. So I want to run this guy to say 2 significant figures. So let me see what we are going to have. So you can see here I have 2500. So you just round it up to take these 2 numbers because this 4, after this 4, I'm going to just use the 2 numbers here. So I have 4. But after this 4, I have this 6. This 6 is more than 5. It converts it to 1 and add it up to 5. And the others here becomes 0. I have 2500. So that's what signif function does in R. So it takes signif function as the third argument. Then this one is optional parameter. So what do I want it to do? I say, okay, percent should be function that is fun, not actually function. So fun is actually doing the work of signif here now. So I'm saying, okay, multiply x times multi-factor. Now, multi-factor by default is 100, right? Now, I'm not saying, okay, dot, dot, dot. This dot, dot, dot is that if I specify another argument, say here, that is going to be working here, so let's say 4. It means this is going to round this operation to 4 significant figures. Then it's going to paste the results with the percentage sign. So let me run this. Now, let me remove this part. So I want to use the function now. So inside this function, I have one parameter called this vector 1, 3, and 4. So that's just this x. So I always specify x. Now, since I always specify x, now these two other parameters have default value. The default value
They are
of
not. They are not collaborating.
Are you talking to me, sir?
Mm.
Okay. This multi-factor, it has a default value. So if I don't specify it, it's going to use
Or they. I think there is power tussle also among them, between them.
So this third parameter also has a default value. The default value is signif function. So if we don't specify a function, it uses signif function to work.
Has more. They have more power actually,
Okay,
and
so
their own policy can actually undermine SEC.
so if I should run this now, it's going to use x as this vector. Then multi-factor is going to take 100 as the value. Then for fun, it's going to use this function called signif. So it's going to multiply 100 by 1 and 3 and 4. Then it's going to just place the percentage sign with it. So I'm going to have 100%, 300%, and 400% as my value. So as you can see it here. Okay, good. So in here, I want to create a profit variable. Okay, so let me run this. I create a profit variable. Then here, I'm saying, okay, car percent should work on profit. Then my fun function is going to be this function. It's going to be this. Now, instead of it to use, I created a function called car percent, but the fun function is signif. But since I've defined my own function here, it's not going to use that signif function again. So it's just going to use this. So it's just going to do x, which is my profit, divided by the sum of profit and multiply 100 and just paste the percentage sign with it. So it's going to even skip this line. It's not going to do this. So let me run this now. I can see. Just multiply.
Hello?
Yes, can you hear me?
Hello?
I can hear you. Can you hear me?
Okay, yeah. Sorry, this central bank circular that was released. So I had a call from the office on cryptocurrency.
What did it say?
But it's okay now.
Okay. Oh. That is good. Okay. But here, what is going to happen here is that it's going to take my first parameter x is going to be profit divided by the sum of profit, and it's going to go on to do this. Then take my x as profit as an over sum of profits here, then multiply by default value of multifactor 100, then come here and do this. It's not going to use this parameter because I didn't specify it. So this should give me the same result of this. So let me run this. We can see I have like similar results. This one was not rounded up. This one was not rounded up because I have to do profit divided by sum of profit. So I will have decimal place. But this one was rounded up using the round function. So that's why I'm having decimal here. Okay.
Okay.
All right. So here Uh, I want to get a vector called round. I create a vector called round. Now I'm creating this function. It's going to take what's it called? It's going to take a parameter x, then another variable multi-factors equals to 100. You shouldn't do this like normally. We shouldn't be doing this. We shouldn't do round is equals to this. We are trying to use a keyword in R to want to place it as a variable. There's going to be a confusion somewhere. So if I what the reason I said is that if I should do if I say round now and I run it, I'm having a vector. Whereas there's a round function normally. So let's say I want to do round of round. So let me do round of round. You can see it has rounded up this value. So you rounded this one to 0, then this one to -1, and this one to 2. If probably I wanted to round it up to 1 decimal place, I'll do this. So that's rounded to 1 decimal place, but there's kind of confusion. So you shouldn't be doing this. You shouldn't use keywords as a variable in R. So someone reading this will just get confused, like what's this person saying? Round into round over. So it doesn't really make any sense. It's going to work for them. It's only you that will understand what you are doing. If anybody's reading it, might get confused. So yeah, and I still did the same thing. Take function to be round, then it's going to work on this and all of that. So let me take this function. And okay, let's do this. So you can see what's happening here now. It said error in function this could not find function fun. Could not find function fun. And what actually happened is that so it shows an error as the two round objects are indistinguishable for the function object, that is for the fun object. So my function could not tell the difference between this guy and this guy. So I don't know whether fun is the round function or fun is going to be this round object that I've created here. So that's why I said it is not advisable to be doing this normally. So you can see that inside the function is now confused. Which one is you? Now this one is not. When I did round into round here,
Can this line, you can't break it into two into this thing? Will it affect its running?
which line?
The calc percent, where your cursor is.
Okay, this
Calc
one.
percent
Okay.
in round is so long. If you break it into two, will it still run? I know some program don't run. If you break it.
Where should I break it from? Like this line? You mean
No,
this
because
line?
it runs so long. I'm not seeing the entire thing.
Is it this one?
The one on top. No, the one on top.
Okay, this one.
The one on top, the round, yeah, that one.
Okay, you mean
I'm saying from
this place, can't see the entire.
Yeah.
Okay, this is just a comment, so I can just do something like this. I can just.
Oh, okay.
I'll just
put
remove
it
the
on
comment
top
and put it on top. I think that would be better. I will just come and put the comment on top here. You can see this creates a vector by rounding up. So you can see that my function did not run because it was not able to tell the difference between this round and this particular round that is here. But me, to my own understanding, I'm trying to say that this round is me that understand what is happening. This round, it is this variable here. But this round here is the round function. But I could not tell, computer programs they are not smart. You are the one that is programming them. So you have to make them understand what you are trying to do. So you doing this, you're just confusing the program. The program will get lost. So that's why it was not able to do what you told it to do. So peradventure, if I should change the name of this guy to round 1, and I run this now, then I create this function again now. So let me create this function again now. Okay, Then let me change this to round 1 and run it. What happened? Could not find function for one. The okay, I have to remove that object. So let me remove that object. That object round that I created. I have to remove
You
it.
comment it out.
I have to remove it. RM function to remove it. It has been removed. So let me run the function again. Okay, you can see it now. So before it was taking round as the object I've created before because I didn't move on the workspace. It was seeing it as a vector. Whereas inside this function that I created, I'm using it as a function. So it's not confused. Which one am I using the round function so by default it's going to take the guy in the global environment, which is the variable, the vector I created. So it's going to take it as the vector. It's not going to take it as not going to know that you are trying to call the round function because the round object has already existed. So okay, so that's all for that. I think enough of this. Let's see. Yeah, let's take a look at this. Here I created a vector called first, which has some set of numbers, another one, second, and another one standard deviation values, which has this numbers, set of numbers. Then I want to create a function called div sub standard deviation means. And what is it going to do? Okay, it's going to take in 3 parameters, 3 arguments, x, y, and whatever. Okay, what is it going to do? This one is so inside this function, I have another function called sub standard deviation mean. And what is it going to do? It's going to take a parameter z, right? And it's going to do z minus mean of whatever. That is, whatever this one is going to take on is going to minus mean of this whatever from it. Now, in the next line, and I said I'm not using this function inside this next in this next line. Say this is going to be substandard deviation mean of x divided by substandard deviation mean of y. So what's going to happen is that it's going to do it's going to perform this function on x, and x is already provided here. So it's going to do x minus mean of whatever divided by y. You're going to use the y here, y minus mean of whatever. So that is what this function is going to do for us. So if I should run this now, so if I should use this function on first, second, and value, so what it's going to do is that it's going to say first minus mean of standard values, then second minus divided by second minus mean of standard values. So if I should run this now, I have this. Do you understand?
Mm-hmm.
All right. Then this I've already explained this in part of our class. This shows the structure of the difference and shows the structure of the sum function. So okay.
So did you reach out to these other people?
I
Look
reached
like
out,
it's only me that's being.
I reached out to like 2 of them. Let me reach out to. I didn't reach out to one last person. So this person said I need to discuss something with you. I'll call you in the evening. I don't know what Farida is doing. Farida is supposed to join us, but there's one other lady. I've not reached out to the person. I don't know. Probably she's kind of busy. All right.
Okay.
Yeah. So this is takes us to the end of our session 1 in module 3. That's working with functions. So the next in line is going to be descriptive statistics in R. So let's see that. That will be this.
Can I take a break of 5 minutes?
Okay, yes, sure you can.
Okay. Thank you. I need to go to the loo.
Okay. Okay. Hello, are we back? Uh, Hello. Hello, are we back now? Are we together now? Hello. Okay. Hello, Mr. Tunde, can you hear me? Can you hear me, Mr. Tunde? Okay. So yeah, talking about descriptive statistics in R, I want to use a data set called Claim data set. It's available with you. You should have it. I think I sent the data set zip file to everyone. So you can have it locally on your PC and use it to practice on your house too. So here I went the data set into R, and here I want to see the column names that are in the data set. So I can use the names function, or I can use the code names function. So I can use the names function, or you use the code names function. So I use the names function, which gives me this column names. So you have patient ID, you have age, you have distance from clinic, days admitted, number of medical bills, claim amount, year and the month. The same result I can get using the code names function. Code names, code names, then health, Then this is also going to give me the column names of columns. And see how this one is here. And here the head here is going to return the first 6 records of my data. So I can specify the number of records it should return by specifying another parameter. If I eventually need the first 7 records, I'll just put comma 7 here. Or comma n is equal to 7. Anyway, you see it. So I should run this now. I have the first 7 records as you can see here. But I just want to see the first 6 records. Okay, this is the first 6 records. I have patient ID, their age, their distance from clinic, days admitted, number of medical bills, claim amount, year and the month. Month 12 means December 2013. So in this health claim data, I have 50,000 observations as you can see in my environment here. I have 8 variables. So if I do table function here, okay, I'm performing a table function on the what? The month on the month column. So this should give me aggregate the month column for me. So it will be month 1 to month 12 and give the number of times they occur in the data set. So if I should run this one, I can see month 1 we have 44,140, of course 4,140 times. This means the patient visits the hospital 4,140 times in month January. Then month February I have this. But most of the visits occurred in month 12, that is in December. Okay, I can summarize my table, get the summary of my whole table. If I want this, have this summary. Patient ID is it's not useful to me. The summary of your patient ID is not useful to me because it's just an ID, it's a primary ID. So there's no information can give me. Age. The minimum age I have in this table is 21, and the maximum age I have is 107. It's normal because you can see the mean and the median are closely same. So there's no outlier. And the minimum distance from pin I have here is 0 and maximum is 629,000. And days admitted minimum to maximum 11. So maximum days the patient was admitted was 11 days. Number of medical bills, claim amount. The maximum claim amount I have here is 256,000. Over 256,000. Then the year I just have there is just this data is just for year 2013. Just for year 2013. Okay. Now what do I want to do here? I want to create a data frame called age amount. So this is going to have age and the claim amount column. So the age and the claim amount column is going to be in this variable called age amount, right? When this has been created, let me to the earth. So I have ages of patients and their corresponding claim amount. So here I want to do a co sum of age amount. I want to do a co sum of age amount. Age amount. That's the age amount data. That is this. So this is going to give me a sum of all the ages and the sum of all the claim amounts. Okay, so if I want this, so I have the total age here to be this, and the total claim amount here is over 76 million. Yeah. Here, what am I trying to do here? I want to know what I said. Health claim, a person claim amount for which health claim a person claim amount greater than 0 and health claim a person claim amount less than 3,000. So it means I want to see the claim amount for between 0 and 3,000. So I want to see the claim amount that are between 0 and 3,000. That's what is going to do for me. So I want to assign it to this variable. So this is going to store the claim amount that are between 0 and 3,000. So if I should run this now, it has been created. So if I should let me see what's inside. You can see the claim amounts inside here are between 0 and 3,000. Okay. Now here I want to have a variable called low claim amount. And what is it going to do for me? I said I want to concatenate or combine sort claim amount. That is this this one that I created that has claim amount between 0 to 3,000. Give me the first 5 for it in ascending order, and also give me the last 5 in ascending order also. You can see decreasing is equal to 2. So give me the last 5 also when you're sorting it. So I want to see the top 5 guys and the last 5 guys. So the one that got the lowest between 0 to the top 5 people that got the lowest between 0 to 3,000, and the top 5 people that got the highest uh between claim amount of 0 to 3,000. So this is going to store them inside low claim amount variable. If I should run this now, it has been created. So let me see the data. So this is what I have. So the least 5 I have is 1, 1, 1, 1, 1, 1. That is 5 ones. Then the top guys that I have, they are almost close to what's called 3,000. This 2,999, 2,999, 2,998, and this. Okay. So I want to plot low claim amount. So I want to plot this. Let me plot this Windows. Let me plot or create a Windows function so that it should be more to look so mature than plotting it here. Let me run this Windows function now. Okay. And let me now plot this. So this is what you have. This is what I have. So these are the lowest guys. That is the top 5 lowest guys, and these are the top 5 highest guys. Just above here. Okay. Here I want to load the data, and in this data setting I'll call faithful. And what is inside the faithful? Let's see the top 6. This is the top 6. It has eruptions column and the waiting column. Yeah. Where is initial. So summary is going to give us the 5 number summary plus the mean. And here I want to assign this eruption column. So I want to call the vector. I want to call out the vector. I want to call out the column as a vector and assign it to this variable called eruption time. Okay. When I do this now, it has been assigned. So here I will be able to see the first 20 eruption time, and this is the first 20 eruption time that I have. So here, what am I trying to do? I'm trying to create a sequence between 1.5 to 5.5, having an increment of 0.5. So let me see the sequence. I have this 1, 2, 3, 4, 5, 6, 7, 8. I have 9 there. So here, I now want to cut my eruption time. This eruption time that I have here, let me cut it out. This data, this vector eruption time, I want to split it into interval using the cut function. So I want to cut my eruption time based on this stopping sequence that I created here. So I want to cut it based on this stopping. It said create an object eruption time called. I think this right is equals to false is I think is to make it open at the right in your interval. But let's see. It has been created. So let's see what is inside this eruption cut. So you can see the interval starting from it's going to split from 1.5 to 5.5. So the highest you are going to see is probably 5.5. So all the eruption time that falls within the interval, it represents it in this way. So the first guy means the first eruption time falls between 3.5 to 4. The second one falls between 1.5 to 2. It's just use this sequence to cut them. Now I want to aggregate the data and see which what eruption times, and so give me the number of eruption time that falls between a certain interval. So for example, this 3.4 to 4, what are the eruption time that falls between this interval? So the table function helps me to aggregate that. So I'm going to run this and it's going to assign it to this eruption time frequency. So let's see what is inside. So this one is saying that uh, um, eruption time in the interval 1.5 to 2 is 51. We have 51 of them. Then the one between 2 to 2.5 is 41. 2 to 2.5 to 3 is 5. And you can see the last one, 5 to 5.5 is what? Is 4. So that's why this right is what is equals to false, because you can see that it is open at your right here. The interval is open at your right. So if I should put this one to be true, for example, I'm going to be true, C to be true. Let's see what is going to create for us. So let's run it again. Eruption time cut, and let me create the table and let me run frequency table. You can see now, you can see that it is open here, whereas it is closed here. You can see it is closed here with a square bracket. So since it is closed here, it's going to be open at this other end. You can see that this one is open, but this one is closed at this point. So that's the essence of that. Now, here we want to do a cum sum. We want to do a cum sum on the eruption time frequency. That's the table that contains this aggregation. So you want to do a cum sum. So you're going to do a cumulative sum. You know what cum sum is. So let me run this. Let me see what's inside the cum sum table. You can see the cum sum. First of all, the first one 55, then 55 plus 37, you have 92. Then 92 plus 5, 97. Then 97 plus 9, 106. Then to the last value here. Then we have cumulative relative frequency. And cumulative relative frequency is this. It's just like a moving average. We are just called like a moving average. So what it does is that this for the first guy it does 55 divided by 1. By the time it gets to this guy, it's going to be 95 divided by 2. Then the third guy, 97 divided by 3. Then to get to the last guy. So that is what this is going to be for you. So okay, it has been created. Let's see what is inside. Uh, oh, no. This is not what it's actually doing. I, I was thinking of a moving average. It's not a moving average. So it's dividing it by the number of rows that you have. So like the number of records that you like. How many do you have here? 1, 2, 3, 4, 5, 6, 7, 8. Is it? Oh. Sorry. The number of row of the faithful data set. The faithful data set has how many records? Again, let me check. Let me check n row. It's divided by 272. Yes, it's 272. So what it's doing is more of like that's cumulative relative frequency. Exactly, cumulative relative frequency. We're going to divide it by then just like a proportion. So divide this by 272. By the time it gets to this place, it's going to end up to be 1. So by the time you divide this by itself, you have 1. So that's my cumulative relative frequency actually. So if you want to do like a moving average, then you have to do something like divide by sequence along the what's it called, the cumulative frequency. So for example, if I want to do this, I will just, if I want to do a moving average, I'll just do this divided by sec along, say this. So this is a moving average. All right. So okay, going to this, what are we trying to do here? So cumulative relative frequency 0, we want to combine 0 with our cumulative frequency. So we start from 0. So instead of going to have 0 0.20, 0 0.3, then it's going to start from 0. So as applying 0 to it, so I can have 0, then this, then up till I get to 1. Here now I want to now plot my sequence together with my cumulative frequency. Then I'll call it old faithful eruption. Then I'll call the x label eruption time minimum, y label to cumulative eruption proportion. So this is going to be my x, this is going to be my y. So this is going to go from 0 to 5.5, while this is going to go from 0 to 1. That is what I have here in this my console. So let's see. So I'll be able to see this kind of graph. I can add a line to it, which is going to connect the dot. So that will make more sense. So this is create a plot of my sequence along the cumulative frequency. So I can add a dot to it and just put, I'll just put type is, I can just type is equal to go. Yeah. And then it makes more sense this way, and if you like it like that. Now, okay, they actually did this to add lines to it. So join the points through a line. You can do this too. I think that one has already solved that instance. But so what did is as okay, probably I didn't put this type. Let me remove this type. Oh, I want to remove this. Then let me run it again. So this is what your graph is going to look like, right? And let me add lines. Use only the lines command. Then you have this. But if you just want to do this once for all, you just have to put that type that I used before. Type is custom, and you're going to have that kind of result just at the first instance. Okay, I think we are almost done with the lab. Then here, this is going to create a tabular format for the first 4 records of the faithful function. Let's see the first 4 records. This is the first 4 records. So this is going to create a table of this guy, this column with this column. So let's see what it's going to look like. This is what it's going to look like. This is like a quantitative table. So 3.6 and 79, they occur once. 3.6 and 79, they occur once. But for the rest, they do not occur. 3.6 and 54, 3.6 and 60. So just going to create like more of an identity matrix because it's unique. 1.8 and 54 occur once. This and this occur once. So this does not really make more sense. It doesn't really make any sense anyway. But when you are doing some kind of working with categorical data set or trying to do a chi-square test, it's going to make more sense. So it does create a consistency table for you. That's when it has just 2 columns. It creates a simple consistency table, but if it's more than 2 columns, then it becomes more complicated. I think we've talked about consistency table before. Now you have the apply function. This apply function, I'm applying it on this data set called faithful, and this faithful has 2 columns, eruptions and weighting. Then I have a second parameter, which is the margin parameter. So since I'm putting 2 as the margin, it means I want to do it on a column basis for each column. So then what am I trying to apply on each column? I want to apply the mean on each column. That is, give me the mean value for each column. So it means on the faithful data set, it's going to give me the mean of each column. So it's going to give me the mean of eruptions and the mean of waiting column. So if I should run this now, you can see I have the mean of the eruption column and the mean of the waiting column correspondingly. Okay. Aggregate function, aggregate function is going to give you the same, should give you the same result, but then I think apply function is more easier. Then this one, we want to work with m recute data set. So I'll just load it. I'll remove this. Okay, it has been loaded. Let's see what's there. This is what is there. So we have the admit column, so whether the person was admitted or the person was rejected. Then we have gender, male, female. We have the, what's it called, the department of the person. Then you have frequency, maybe the number of times person was number of times person was admitted, number of times person was rejected, and all of that. So it's just like, okay, probably some students applied for a particular for a particular course in a school. So in the arts department, people that apply for arts that are male, so 512 was admitted, while 313 was rejected, and for female students in arts, 89 was admitted, while 19 was rejected, and the likes of that. Now, here, I now want to create a course tabulation for the x tabs. Use the x, called the x tabs function. So here, what is it going to do? It's going to use frequency, the frequency column as values, then give me the gender is going to be on the row side, while the admit column is going to be on the column side. So here is like I'm saying, okay, I'm using the encode data, so I'm specifying the data I'm using as the second parameter. So what is this going to do? Okay, for male students, so it's going to I'm going to have a table like this: male, female on the row side, then admitted, rejected on the what, on the column side. So I'll now have, okay, males that are admitted, what are their frequency? That's going to be the value. That's why frequency is there. So I'm modeling frequency against gender and admit column. So male students that are admitted, what are the frequency? Male students that are rejected, what are the frequency? Then female students that are admitted, that's what it's going to do for you. So let me run this so I can see. You can see what we have here. So gender is on the row side, admit is on the column side. Then their values, set of values are the frequency. So I have females that are admitted, we have 557. Then what's it called? Males that are admitted, 1,198. While male guys that are rejected, we have 1,493. Yeah, makes more sense, right? So that's cool. Now, if you want to see them by, let's say you want to see them by their department, then probably instead of, I don't want to see by gender, I want to see by department, then I just have to copy this and just maybe change this to department. I just put DEPT here. Okay, so you have something like this. So we have accidents that were admitted, 601, and those that are rejected is this. Bank students that were admitted. You can include, probably you can do it by gender also. So if you want to do it by gender, I can, let me see. I can include gender. Maybe I should be able to do that. Let me see how this works out. Okay. So so this one, it does for the female people, that's the female gender, it gives you the breakdown. Female accidents that are admitted is this, while those that are rejected is this, and after, so do the aggregation for female, then after it's done, then just for male also. So that makes more sense. Are we together? Are we together?
Yes.
Okay. So this gives me the summary of the X tabs function. So here I'm modeling the frequency against every other columns in the M recruit data. So this tilde sign with the dots means I'm modeling the frequency as value against all the other columns in the M recruit. So it's going to use all the other columns. What are the other columns that are in the data? So it's going to do it against gender, department, sorry, admit, gender, and department. So but I'm using the summary function to get the summary of the whole stuff. So this is the summary of the whole thing. This even does the chi-square test on it. So, but then let's see what this is going to give us. What is this guy? What is inside this guy? You can see it does the what, the admit and gender uh, aggregation for each department. So first of all, it's going to start from department, the arts department. How many female are admitted and how many female are rejected? How many male are admitted and how many are rejected? Then go to the next department until all the department is exhausted. Okay, yeah, I think that is the end of this lab, and I hope you all got one or two things in this lab.
Yeah, quite interesting.
Yeah, yeah. So uh now the next thing is now what do you call functions, groups, and data frames. Functions, groups, and data frames. That will be the next lab here. Uh, so working with data constructs in R. So let me see that. Yeah, data constructs. This. Yeah. I don't know. But I have to be very fast with this. Let me see whether maybe I should just skip this one. Let me see what's inside. Uh, what is inside this
Which
guy?
one that you call up? Is it the data on the data set is already part of what you call up now?
Which one is
Okay,
that?
like the salary. Okay, like the salary, personalities. These are the datas that we person names, all those. Okay, okay,
Mm,
don't worry.
okay. So I don't think this one is you can all practice this one on your own. This lab, this data constructs. So let me just skip this one. So I'll go to graphical analysis in R. So that will be this guy. Okay. Uh, okay. Let me just go to this one. Yeah, let's see. I think we should be able to finish this one anyway. So let me graphical analysis in R. Okay. Uh, 1069. Okay. If I copy it two times, I think I copied it. Okay. This thing is, this thing is plenty. 1069. Okay, we start here. So here, I'm also using the daily spend data.
You use the source function to load it.
No. I just copied and paste the
And
code.
okay,
It's a TXT file. It's not.
yeah,
It's not.
or something for.
Yeah, it's not the alpha. I use an alpha. I'll just come. I can just press Control O on my system. Then I'll just browse to the file like this. I just browse to that file and open it in my app.
Okay.
Yes. Okay, so let me do the daily spend data. It has been loaded. Let me see the first 6 reports. This is what's inside. I think, okay, we have person ID, person name, daily needs spent, then the daily earnings. It has just 10 observation and 4 variables, as you can see here. Then I want to create a profits variable, which is going to be the daily earnings minus the daily spend, the daily needs spend of that person. That will be the profit. Let me see the profit. These are the profits. 470.20 of this. Then I want to call the person's name as a vector. I want to call it out. Okay. Then here I want to plot the person's name and the corresponding profit. Are you with me?
Yes.
So the person name will be on the x-axis, then the profit will be on the y-axis. Since person name is a categorical data and the profit is a numerical data, so this one will be like an histogram. So I'm going to tell the plot function, because I'm not using hist function. I'm going to tell the plot function that I'm trying to plot an histogram using a type H. Are you with me? So this thing can come out in the exam. So what is the importance of, or what is the significance of this type parameter in this plot? Something like that. So let me run this. Uh, oh, what happened? Error input need x limit values. Uh, x is now x is now. Why is it giving me issue like this? What should I do? Profits. This profits. Person's name. So how many of them? 12, 7, 10 out of 10. So let me just use the histogram function. I don't know why it's giving me issues. Person names, comma, profits. Let's see how this works out. X must be numeric. Okay. I think I just have to use one parameter here. I have something like this, but this is not what I want. Okay. Uh, I don't like the way it is. So let me just use bar plot. Bar plot. Happen again. Uh, okay. How about this? Okay, this makes more sense, but then let me put person's name here. Person names. The way I want it to come up, I want it to bring the labels. Or I'll just do something like this. Uh, uh, I'll give it a name. I'll give it a name. So I'll say names of profits. So to make it more meaningful, names. Sorry, let me go to the next line this way. So I'll name the vector names of profits. Profits column. I'll give it the name should be person names. Person name. So that will be like our label. So okay, so let me do the bar plot again. All right. So this makes more sense. So Anish, this is the profit of Anish, this is the profit of Jagdish, this is the profit of Barbara, this is the profit of Motor, and you can see the corresponding. All right. Now yeah, let's see how we can do a scatter plot using the raw data one. data set that we have in our working directory. So let me note this data. It has an header. Let's see the column names. AABB. This is just example data to practice for scatter plot. Now I want to plot the AA column with the BB column. Then I want the color of the points to be blue. I want the X label to be named explanatory variable, and my Y label should be response variable. So let's use this. And we are going to have something like this. So these are the points on the scatter plot. It's blue because you specify the color to be blue. You can do this. Then you can use color function also if you like, or if you know the kind of color you want to use, you can just specify it. So you can add line to it, like this shows the relation between two variables BB and AA through a line. So like gives it like the pattern of the chart. So if it's going up, it draws a line like directly up. So if you look at this chart, it's more like that's a positive correlation. So you have a straight line that shows that pattern. So if I use the app line now, I'll use the LM model to say, okay, give me the line of the linear model between these two variables. So if I should run this, you see the line on that chart now. So this is the trend of the chart. Are we together? So this LM model, we learn more about it when we get to book 2, talking about linear regression. Are we together?
Yes, yes.
Okay. So here we want to call another data set called Cohort 2, the TXT file. So I'm using read.table now. If you are using a TXT file, you can use this count function to read TXT file. But if it's more of like a structured kind of format, you can use read.table. If it has an header, specify header to be true. If it does not have an header, just put header to be false. It's going to give it a default header by itself. Like you can say V1, V2, then you can rename the header. But if your table has if your data set has an header, you specify header to be true, so that how is going to take the first record as the header of the table. So please take note of that. Now, if you're using a read.table function to call a CSV file, if I have a CSV file, I want to read it into R, I can use the read.csv function. But if you're using read.tables, because they can confuse you in your exam, they will say, okay, you can ask a question like, I want to read a CSV file that has an header. How can I do this? They will not say, they can say option A, read.csv into bracket, specify the data. Then option 2, they will not say read.table, then specify the file, .csv. Now put SEP is equals to comma in quotes. That too will still work fine, because if I'm using the table to read a CSV file, I have to put a separator that this is a comma separated value. So I put a comma in quotes to tell you that I'm reading a CSV file. And if I'm using read.csv, I don't need to put that step parameter, because it's understand I'm trying to read a CSV file. So please don't get confused if you see something like that. So option A and option B are both correct, because if I'm using read.csv, I don't need to specify the step parameter that, okay, I'm trying to read a CSV file. But if I'm using read.table to call a CSV file, I have to say SEP is equals to comma in quotes to tell that it's a comma separated value. CSV means comma separated value. If you use something like TSV, it means tab separated value. But if you're using read.table to read a tab separated value, you have to put SEP into /T, that is like, is it / or I don't know, /C to show that it's a tab separated value. But if you're using read.delim is to use a tab separated value. So I don't need to specify separator. So don't get confused if you see something like that. All right, so I want to okay, I've not read this part. So let me read this part into part. So I'll read this part into out. So let me see the column names. You have this column name here. Then I want to use the points function. So this is going to do a point plot of the two columns AA2 and BB2, and I'm going to color the point as red. So let's see what it is. So it just added this, because I'm using points. I didn't mean I use plot. It would have erased this plot. and do another plot. But what I did there is just to add the points of this new plot to my existing plot. You can see that this existing plot was not erased because I'm not using a plot function. If I'm using a plot function, it's going to override this particular plot. So if I run this outline function to create a line of linear model between the VB2 and the AA2 variable, it's going to add another line on the same plot. It's going to add a trend on this new red point. So you see another line showing the trend between these red points. If I want this now, the second line is going to be the trend of that second point. So you can see this second line that is downward here. This line is showing the trend of this red point on that same chart. You understand? Are we together?
Yes.
All right. So I think here here we want to use a data set called pragmatic acid, a txt file. It has an header to see. So now this attach function, can you remind us what's the reason why I'm using this attach function on this pragmatic data?
I can't remember.
Yeah.
No.
So what is doing is that if I should run this pragmatic data has three variables, that is three columns. So if I say attach pragmatic acid, it's going to allow me to be able to call the columns in this pragmatic acid data without me referring to the data itself. So for example, what are the columns in this data? Let me call head of pragmatic acid. Look at it, has tracer with index pH. Abi. Now let me try and call pH column, pH, small letter P and capital letter H. What are you saying? Object pH not found. I can't call pH without referencing the data I'm calling it from. So if I want to call pH, I'll have to say pragmatic and put ampersand pH like this. Now pH is now answering me. But now if I do attach pragmatic acid, now I can now call pH without referencing the pragmatic acid data itself. So if I say pH now, you can see pH can answer me. You understand now? All right. So names of pragmatic acid, what does it do for us? If I want this command, what does it do for us?
It brings out the various names in the, what do you call it, arguments.
Okay, it gives us the column names, the name of the columns in that data, right? Okay.
Yeah.
Now,
apart from argument, what other name do we use apart from argument?
it's still
something.
it's still argument. I didn't. It's,
no, there is.
okay,
when they say that if parameter, yes.
Parameter, okay, yeah. So here I want to plot the index column against the pH column. So let me see. This is the index column, and this is going to give us a scatter plot by default. So let me run this. So this is the scatter plot. You can add the color to it if you like. Here now, what am I trying to do?
So from the R Studio, all this data automatically a chart or something is displayed, is constructed, are we?
So like if I run the plot function, I didn't get a question very well.
What I'm saying is that all those things, is it that by default the data, once you run some scripts, a plot, a chart or something is already calculated automatically, so you can choose to display or not display? Or is it okay? There's a plot function that you run here. That's why.
Yes. Because I ran this plot function, that's why it displayed it.
Okay.
Normally, it's supposed to show on this this right bottom screen here. But since I've run a Windows function to where my plot should be showing, that's why it's showing here. So this one, with this one, I'll be able to see it very well. It's going to be very clear. So I just create a Windows screen for myself. Now here, I want to run a text function. And what is this one going to say? So plot a text function trying to plot index against pH, and my labels is going to be facial weight. Are you with me? Say round facial weight to 2 decimal places. I have position, offset, and CX is just the point of those plots. I want to reduce it to 0.7. Then all of this position and offset is to like, now the labels here is going to show the point of facet on those plots. Now this is the scatter plot of pH against index. So I want to see the corresponding facet that is attached to this point. So I want to see the value as a text here. So that's why this labels is picking what's it called? Facet weight. Or is it facet weight or facial weight? I'm rounding the value to 2 decimal places. So let me run it so that I can see. So on that same plot, this is going to show. So you can see some values here. So this is the facial weight corresponding to each of these points. So this CXC points that is here, CX 0.7 is just the size of this point. I will use the size to 0.7. Now this offset and position is telling the position of where this text should be and how far the text should be from the point. That's the offset. So how far should the text be from the point? I don't want it so close or something. So I just set the distance between the point and the text itself. Do you understand? Hello?
Yes, I can hear you. Sorry, I was muted.
Okay, so it's just like, okay, probably let's say for example, I want to plot uh, how do I want to put it? So I want to plot years of experience of an employee against the salary that employee is receiving on a chart. So let's say these points are the years of experience of a particular employee and the salary the person is collecting. But I want to now add as a text I want to know which particular employee is showing in this chart. So this is the essence of this text here. So this text is showing the facial rate of the points that are plotted for index and pH on this chart. So do you understand what the chart is trying to do now?
No, are you saying that the individuals and this thing are reflected?
Yes, these individual numbers you are seeing are the facial rate that are attached to this point.
Okay.
That's why you see labels. Labels is equal to round pragmatic acid facial rate to this decimal place. The text is showing the facial rate that is corresponding to this plot here. So that's what it's showing. Yeah. Okay. We are we have almost exhausted our time. This is 159 already. Yes. So this one I'm creating it's a sequence called first, and I'm creating sequence called second. Yeah, and I want to plot first against second, but I want the type to be a line. So instead of a point, that's why I have type is equal to L. So please note all these parameters. So if I should run this now, this is what I'm going to have. So you can see the plot as a line instead of
Not as it's scattered.
yes, yes. But if I want a line, both line and points together, I'll use type is equal to O in lowercase square. So let me run this so that you can see the result here. So you can see the points connected with a line together this way. Do you see that?
Mm-hmm.
Yeah. Uh, Now adding shapes to your plot. Now if you look at this plot here that I want to do, I want to plot this, sorry, sequence 0 to 20 against 0 to 20. Then X label should be empty, Y label should be empty. Uh, this is just trying to show the line of X and the line of Y. But this type is equals to N is saying that I want it to be, first of all, don't do anything on the plot. Just give me an empty box, like an empty plot. So it's just create an empty graph. So if I should want this now, if I look at the plot, you see it's just a rectangle thing. It's going to be an empty block. Now on this guy, I want to create. So it's going to create an empty plot having size 20 as length and breadth. So your x is going to be length 20, your y is going to be length 20. So I want to plot a rectangle on it having this axis. So if I do this, it's going to plot a rectangle of this size on my screen. So this is the rectangle. I can plot arrow having this shape, this point. So if I go to my plot again, you see another arrow. Can you see this arrow on surface? Then if I wanted to, I think code is equal to 3. It's going to plot another kind of arrow. I think maybe double edge. So let me see this. You can see it has double edge in between. Then you can tell the angle of the edge. So you want to be in angle 80 or angle 60, depending. So if I plot this now, you see the kind of arrow is going to plot. You can see the edge is more flat compared to this one. So if I put angle 90, is more or less going to be like a straight one. Let me reduce the angle to like 45. 45 is going to be like a normal kind of arrow. But full size 15, it's going to be angle 15 is going to be more close. So look at it, it's kind of more close. So this one, you can see that it's close. It's sharper than this one. So it's not like angle 45. Something. I don't know. I don't know the default angle. I don't know the default angle. Let me check the default angle. Arrows. Angle. That just went off. Angle is 30 by default. Yeah, the angle is 30 by default. So let's try to go over this. I know it's yeah. So you just let's take our time to go over the remaining of the lab so that we can understand some things. So it's very important. Let us go through our lab. So the class is about to start by 2, so I just have to excuse them so that they can have their class. So we are going to meet next week. Should we continue the lab next week or we should just move on with it?
Let's continue next week.
Okay, no problem then. So we're going to meet next week again by Friday. I hope you enjoyed this class.
Yeah, thanks. I'll also go back to the video.
All right, that's very